Now in this next example, we're going to use bisection to try to find the root between 0 and 1.5. The correct root location is 0.73, but currently we just have the bracket and the function evaluated at those brackets, roughly 3.5 at 0 and roughly minus 6.5 at 1.5. Regardless of those function evaluations, bisection is always going to choose the middle point, 0.75. There, the function evaluation is roughly minus 0.15. Again, that function evaluation is unimportant. We know we're looking to throw away half of the bracket. And we know since it was positive over here at 0 and it's negative here at 0.75, that root has to be somewhere on the left-hand side. So we're going to throw away the right-hand side of the bracket and we're going to look for a point halfway between 0 and 0.75. There, we're going to see that the function is positive. Again, we don't care that it's quite positive, even though it's true that this root is quite close to this side. We're just going to say it's halfway between here and here. When we evaluate the function there, we see it's still positive. The sign change is still between here and here. So it's still between our newest evaluation at 0.56 and our old friend 0.75. So on and so forth, getting smaller and smaller as we go, getting closer and closer. Now I'm going to resize the bracket. Now we've got one guess at about 0.7 and the old guess at 0.75. Still, we're just going to evaluate at the middle. So far, all our sign changes were indicating that we needed to throw away the leftmost fragment. Now, we'll see that we're going to throw away the fragment on the right. Here we are guessing the middle. And you can watch this number with each iteration getting a little bit closer and closer to 0.73, though it can bounce around. Right now we're about a distance of 0.002 away, and here we're much closer, but then the next time we'll go a little further away. We're dancing around this 0.73. There's no guarantee that in one iteration we get any closer, but it is true that the bracket is getting smaller and therefore our maximum error is getting smaller with each iteration.